Hello, this is Jacob Riggs, and I am here to look at a semi-small assignment from CSE 275 for the algorithms analysis assignment. So what we had to do was create a stack and a queue and input a set of data and output the contents, and then um, pop off um, certain parts of it. So um, when it comes to the big O notation, Um, that would be if this code was altered to take in either or user input, player input. You can see I'm a game programmer, and or like a list from some outsourced file. Um, but I was using this because I understood what we were doing, and I could put it into other terms in which you could apply the big O notation. So say instead of pushing on 1, 2, and 3, we took in a list from a file of different inputs of different numbers, then going through each one and finding the size, which is show queue or show stack, which goes through each one until it's empty, and it counts it as this is this number 1, 2, 3, 4, 5, 6, 7, and so on would be in this. Say if we were grabbing that from a file for both the queue and the stack um, in here, then counting through each one like that would take forever, and would ultimately slow down the program if it was a huge database of uh, information we had to get through, or a large, like say it was like an online storefront or something like that. Going through each and every customer like this would take forever. Um, And so computational resources, it has been a while since I've worked in C++, so I'm not sure exactly what this would use. Oh, but also let me show that this actually does work. Let me show that it shows the numbers in stack is 321 because for the stack we put in 1, 2, 3 and it puts them in backwards technically with a stack, and it shows that there are 3 in this stack. It counts how many there are. There are 3. The top is 3, and then we pop the top, so then it's just 2 and 1 left. Finding out also the size of something that's bigger than just 3 numbers would also take a very long time, even though we do just use size. So, and if we press a key, then we go to the queue, it's the same numbers. We get the size is 3, and it's 1, 2, 3, since that puts them on one after another. It puts them in order. So the front would be 1, the back is 3, and then popping off the front, or the top, it would take off 1 instead of 3 like up here. Um, and then what were the other things to reach here? In what cases, situations, or scenarios would your algorithm's performance be enhanced or diminished? So like I was talking about, if this were to take in user input or like a large file of users or information, that is when this would slow down and be at like a disadvantage, because it does count through each and every one individually to display them instead of combing through it in a, I'm guessing there would probably be a better way to comb through it other than a while it's empty, which means that's to keep checking if it's empty. Um, and at an advantage, it would work better for something like, for this example, that's a smaller set of data. So say if you were just trying to show like a small set of data you had collected through this, this is when this would work well, because um, you're not combing through a giant list. It's a smaller set, so this would work just fine for that. Um, and show the lines or sections. So the ones that would be affected by a large set would be especially the show queue here, because it shows what's in there. It goes through and it gets all the numbers, and then while that's not empty, it puts out another one. And that's the same thing is essentially the same thing down here for the stack. Um, so that would be what would be affected if you had a larger set of data, because that is the part that actually goes through each and every one of them and then displays it. Um, Instead of just, maybe seeing how many are in there or seeing what's at the front or the back, like the smaller pieces here. But no, the show queue and the show stack functions would be what would be slowed down by a larger set of data, because if it was so much, it would have to go through each and every one in there. Um, I think that would be it. I probably talked really fast. I'm sorry about that. Um, yeah. Thank you.